Okay, so question number 21 is not directly related to equations of motion. So we are going to skip it. We are going to obviously cover question 21 in the next series of this video series. Let's move on to question 22. It says in a cathode ray tube, an electron is accelerated uniformly in a straight line from a speed of 4 exponent 3 meters per second to 2 exponent 7. That means initial speed is 4 exponent 3 and final speed is 2 exponent 7. Okay, over a distance of 10 millimeters. So that's very important, millimeters. So we can write it like 10 exponent minus 3 meters. So that's the distance. Then they want us to find out the acceleration. So acceleration is basically given by v squared minus u squared upon 2s using the equation. So it becomes 2 exponent 7 whole squared minus u, that's 4 exponent 3 whole squared over 2 into s, that's 10 exponent minus 3. So what do we have once we solve this? So we are getting an answer of 1.9 exponent 16. That's almost around 2 exponent 16. So do we have somewhat like that? Answer, yeah, it's like D, right? Okay. Then let's move ahead. Let's see what do we have next. So question number 23. Okay, so it says that on a particular railway, a train driver applies the brake of a train at a yellow signal. So let's say that's the yellow signal. So there is the train. So brakes are applied from yellow signal a distance 1 kilometers from a red signal. So that's we have a red signal here. So the distance between yellow and red is 1 kilometer, that's 1000 meters. Then it says where the train stops. That's important. That means here train stops and here it was moving. The maximum deceleration of the train is a uh, 0.20 meters per second square. So since deceleration is given, that's negative acceleration minus 0.20. I'm writing a. So they say, assuming uniform deceleration, what is the maximum safe speed? Okay, that means u is required. So we have, I think, everything using the equation, we can work this out. So v squared minus u squared is 2as, right? So we can just plug in the values. Zero is, v is 0, u is unknown, 2a, that's minus 0.20, and s is 1000 meters. So negative u squared would be, so negative u squared would be 2 times 0.20 times 1000, that's negative 400. So u would be equals to square root of 400, and that would be 20. So do we have 20 as an option? Yeah, 23 is free. Now, let's move ahead. Let's save this. Question 24. It says a person traveling on a motorway, a total distance of 200 kilometers. Okay, travels first 90 kilometers at an average speed of 80 kilometers per hour. Which average speed must be obtained for the rest of the journey? The person is to reach the destination in a total time of 2 hours and 0 minutes. Okay, so there is this guy that is traveling on some motorway and he's traveling a total distance of 200 kilometers. Since answers I'm having in kilometers per hour, so I'm not planning to change this. Now, it says the first part of the journey he travels is 90 kilometers, and that was with the speed of 80 kilometers per hour. So basically, as you have gone through my previous video, this is a type 1 question. Type 1 question basically involves only using s is equals to vt. So first let's figure out what time does this guy take to travel 90 kilometers of the part of the journey. So that would be t is equals to s over v. Distance he did was 90, and speed which he used was, travel was 80. So 90 over 80 comes out to be 1.125. Since it clearly mentions in the question that he is, moving with an average speed, that means there is no acceleration, right? If there is no acceleration here, uh, at least not given, so we can assume acceleration to be zero here. So that's the time he, kind of took to travel 90 kilometers, 1.125. So the total journey was 200 kilometers, and the total time was 2 hours. So the journey left here would be 90 kilometers are already done, right? So that's 110 kilometers. That's part of the journey that's left. And time, since total time is 2 hours, so let's subtract 2 minus 1.125. So the time remaining is 0.875. So the speed he needs to travel with for the remaining of the journey would be 110 over 0.875. So 110 divided by 0.875 comes out to be 125.7. That's almost 126. That's D, right? That's nice. Let's move ahead. Question number 25. Okay. So question number 25 says that one object moves directly from P to R. Okay. Let's move this directly from P to R. That's nice. Then what happens? In a shorter time, a second object moves from P to Q and then Q to R. Okay. So the other object is going like this, P to Q and Q to R. Okay. And the other piece of information which is very important is they clearly said that this red path is the, you know, shorter time path. So that means object is moving faster here. Okay, that's nice. So he's moving, the object is moving faster, which statement about the two objects is correct for the journey from P to R. They have the same average speed. So that's virtually not possible. If they have the same average speed, then the distance traveled from P to Q and then Q to R should have been, kind of longer, right? In a longer time. They have the same average velocity. That's incorrect since direction is changed, so there is nothing like average velocity being same. So that's incorrect. They are the same displacement. Yeah, that looks correct. Going from P to R basically is a single displacement, and going from P to Q and then Q to R is the same displacement, right? So the displacement is directly from P to R. It's basically the start of the motion till the end of the motion. So the initial path it started was from P and it all the way moved to R. So it should be only C. That's correct. They travel the same distance, so this all are incorrect, right? Let's try question 26. It says an aeroplane travels at an average speed of 600 kilometers per hour on an outward flight and at 400 kilometers per hour on the return flight. Oh, wait. That means, let's say that's the plane, and plane moves from, an outward flight with 600 kilometers per hour. Okay, that's nice. That's outward. And for the same journey, inward flight, the plane is traveling 400 kilometers per hour. That's nice. So inward. Okay, fine. So the distance is same. Outward flight means, a plane may be bounded from Karachi to Islamabad is an outward flight, and coming to Karachi back is an inward flight. So it's essentially the same distance. So since it is going faster, so, it will require a different time to reach Islamabad maybe. And since it is coming slower, that will require more, maybe a greater time. Okay, let's see what this asks us to do. What is the average speed? Now most of the students they do is they think that just find out the average, that's 600 plus 400 over 2, so they end up with 500, and that's the incorrect answer. Reason this is not correct is distance covered is same, but time in going and coming back is not same. So we have to find out basically the average speed of the whole flight. For that, we need total distance over total time. So we are going to use this formula. That's still type 1 question because it only involves this formula. So distance is not given. So let's assume the distance, in between those cities is D. That's it. So for an outward flight, it travels D, and for the inward flight, it again travels D. So the total distance it traveled is 2D. Now, let's figure out the time it took to go outwards. So time would be distance upon speed. So that's D upon 600. So that's D upon 600. That's the time only to fly outwards. Then to come back, it should be again time. That's D upon 400, right? Let's try D upon 400 here. So once we solve this, this is going to be 2D over D into 1 over 600 plus 1 over 400. We can just factorize it. This gets cancelled. Now we don't have to use, any complex calculation. Just figure out 1 over 600. So it's like 2 over 1 over 600 is 1.66 exponent minus 3. Or maybe you feel that your calculator is making some error. but it's not. If you find something like 0.0016, it's the same answer, right? It's the same answer. It's the same thing. No, no, don't worry about it. Then plus 1 over 400. So 1 divided by 400 is 2.5 exponent minus 3. It's the same answer as well, right? So if we add them up, 2.5 exponent minus 3 plus 1.66 exponent minus 3, what do we have? We have 4.16 exponent minus 3 divided by 2. So 2 divided by answer comes out to be 480.76. That's answer C. Very important concept. 480.7, right? Let's save this. Let's move ahead. Okay, let's try question 27. It says there is a diagram that shows an arrangement to stop trains that are traveling too fast. So speed 50 meters per second, marker 1, marker 2, maximum speed 10 meters per second. Okay, so at train coming from the left travels at a speed of 50 at marker 1, the driver must apply the brake so that the train decelerates uniformly. In order to pass marker 2 at no more than 10, the train carries a detector that notes the time when the train passes each marker and will apply an emergency brake if the time between passing marker 1 and passing marker 2 is less than 20 seconds. So the time allowed here, if it's less than 20 seconds, that means the emergency brake, is going to be switched on. So we have this time here, and they want us to find out the distance. So we have everything we can use. That's initial speed, that's final speed, and they want us to find out the distance. So first, for that, we can use A is equals to V minus U over T, where V is 10, U is basically 50, and time is 20. So that's minus 40 over 20, and that's going to be minus 2 meters per second squared. And then they want us to find out the distance. So we can use V squared minus U squared upon 2A, one of the favorite formulas I love. V is going to be 10 squared minus U is basically going to be 50 squared over 2 into A, that's minus 2. So that's, if we solve this, 100 minus 2500 over minus 4, it is going to be 600 meters. So that's basically, do we have 600 even as an option? Yeah, D. That's nice. That's correct. Good job. You read it correct. Let's try question 28. So question 28 is basically, I must say that it is basically a type 2 question. Now in type 2 question, we have a combination of S is equals to Vt and the acceleration wala part, acceleration equations, things like those. So, we have to use a combination of both. So it says a goods train passes through a station at a steady speed of 10 meters per second. An express train, steady speed, that means this is the S is equals to Vt part. An express train is at rest, that means that's 0. The express trains leave the station with a uniform acceleration of 0.5. Just as the goods train goes past, both train moves in the same direction along the horizontal paths and all. How much time? So they were interested in time. Okay. So what should we do? So basically, this starts from rest and there is an acceleration. So distance traveled by goods train should be equals to the distance traveled by the express train, right? Then only we can say whenever it has to overtake it, so it is going to be beyond that point. So goods train is basically solved by Vt. This can be done by Ut is equals to half At squared. So I know V, that's 10, T is unknown, this is 0. So half A, acceleration is given 0.5 T squared, right? So let's cancel this T up. So that is going to be 10 is equals to 0.25 T. So 10 over 0.25 is going to be the T. So 10 divided by 0.25 is basically 40 seconds. So that's basically the decision where they are going to overtake. Now it says in question 29, a bicycle brakes so that it undergoes uniform deceleration from 8 to 6. That's U, that's V, over a distance of 7 meters. If the deceleration remains constant, what further distance will it travel before coming to rest? Okay, that's nice. Let's save this and let's bring this up. So first part of the journey is where it has, traveling with U and V, and it decelerates So let's find out the deceleration using the given data. V squared minus u squared upon 2s. V is 6, u is 8, and 2 into s. So that's 36 minus 64 upon 14. 36 minus 64 divided by 14. So that's negative 2. Acceleration, negative 2. Deceleration is 2. Okay. Then it says that the deceleration remains constant. That means now that's the other part of the journey. What further distance? So if the deceleration, let's say the deceleration is staying constant here, it has to come to rest here. So the now final speed of the previous part becomes the initial speed of the next part of the journey. So these deceleration is basically minus 2. So they want us to find out distance. So let's find the distance out again. V squared minus u squared upon 2 into a. V is basically 0. U is basically 6 squared over 2 into a. That's negative 2. So that means negative 36 over negative 4. That's basically 9 meters, right? So the answer should be 9 meters. Do we have 9 even as an option? Yeah, we have one. So that's B. 29 is B. Let's try 30. So in question 30, it says a science museum designs an experiment to show fall of feather in a vacuum tube. So fall means initial speed is 0, and acceleration is acceleration due to gravity. In downwards direction, that's taken positive. I'm assuming it to be positive in downwards direction. The time for fall is rest to be close to 0.5 seconds. Well, that's given. Then they want us to find out the distance. Okay, let's see. Based on the given data, we can use ut plus half at squared. That's going to be the best part here. This becomes 0. This becomes half. 9.81 times zero point 0.5 squared. So that's basically 9.81 divided by 2. That's 4.9. Then 4.9 times zero point 0.5 squared. So 4.9 times zero point 0.5 squared is going to be 1.225. So do we have something like that? 1.225 can be rounded up to 1.3. Now, question 31, which is basically a very simple question, but it looks very difficult. And most of the students, they find challenge in this question, which they shouldn't be. So there are two markers, M1 and M2. They are set up a vertical distance h apart. That's M1, that's M2. A steel ball is released at time t is equals to 0. That means here, the initial speed is 0, right? And acceleration is 9.81 meters per second squared, and the distance is x, right? So the object that reaches from this point to this point reaches in t1 seconds, right? Now, that's one part of the journey. Then it says it reaches part marker 2 at time t2. That means from all the way here to here, the time is t2. Which expression gives us the acceleration? Okay. So we are not allowed to use this. They want us to find out acceleration in terms of the equation we have. So basically, what we can do here is for the first part of the journey till it reaches the marker m1. So I have u, I have s, and I have t, right? So I can work out an expression involving all three of these. So I can use s is equals to ut plus half at squared for this part of the journey. I'm going to just plug in the values. That's 0 because u is 0. Half a is unknown, time is t1 squared, and s is x. So I have one of the equations that says x is equals to half a t1 squared, right? Now, if I want to move further, what happens next? So this distance is h, right? So here, the initial velocity is not now 0, but the initial velocity is somewhat like some final velocity here, which becomes initial velocity for the other part. However, the other part is if we plan to solve this entire distance, let's say we are solving an expression for this distance. So u is still 0 here, and the total distance would now be s, that's x plus h. Time is going to be t. So using the same equation that says s is equals to ut plus half at squared, what we can do here is that's 0. S is basically now x plus h, since that's the distance we have been talking about, and t2 squared would be the time, right? Now, most of the students, they get confused here because they kind of unknowingly figure out that This is the time between T1 and T2. However, the question clearly states that T2 is the time it took this ball to reach this marker 2. That means from all the way here to all the way here, that's basically T2, right? That's very important. So now we can just substitute the value of x here. That's half a T1 squared plus h is equals to half a T2 squared. They want us to find out an expression for acceleration. So let's bring accelerations on the same side. So h is equals to half a t2 squared minus half a t1 squared, right? So half a, basically let's take a as, kind of outside. So this becomes half a t2 squared minus t1 squared. So a would now be equals to 2h over t2 squared minus t1 squared. So do we have something like that? 2h over, yeah, that's D, right? 31 is D.